Okay, so logarithms. What is a log? So a log is something that was created by mathematicians. It was created so that we can solve for an exponent. Okay, it's a way to solve for an exponent. Some of you may have noticed there's a key on your, couple keys on your calculator actually, that are log keys. We are not going to use those keys for a while. We have to get the base down. We have to figure out the foundation of what logs are, and then we'll get to the calculator stuff. But eventually we will get to that. So what we're going to do is we're going to show you first converting from a log to an exponent and then an exponent to a log. So a log equation to an exponential equation. So log base 2 of 16 is 4. Notice the log and the 16 are all straight in a line. The only thing that's lower is the base. So make sure when you're rewriting it like that, that's how you're doing it.
Wait, 2 is the base?
2 is the base, yep. So in writing this as an exponential equation, our base is 2. And this is where it gets kind of weird. When we have that log, the 4 is the exponent. So this is your exponent. And this part of the log equation is your answer. So it's 2 to the 4th equals 16.
Wait, this is like a log.
So is 2 to the 4th equal to 16?
Yeah.
Yeah, 2 to the 4th is 16. So really all you're doing, really, you've got to know that this is the base, and then you're like switching these two here. So you're putting the 4 as the exponent, and then the 16 is your, yeah, you're just rewriting it. That's all this problem is doing. So number 3, we want to rewrite that as an exponential equation. That's all we're doing on these problems. So here in this group, how do I write it as an exponential equation, number 3?
13 to the 0.
What's my base?
13. 13.
I'm asking this group here. Yeah.
You got it, guys. One bad.
Thank you. Thank you. The base is 13. So 13, and then what part of that is the exponent?
Zero.
This group here, what part of that is the exponent? 0. So this, remember, is your exponent. And then my answer is, yes, 1. Is 13 to the 0 equal to 1?
Yes.
Yeah, so you're always going to get a true statement. Because all we're doing is changing it from log form to exponential form. Okay, so another group. Let's pick another group. This group back here. Rewrite this in exponential form. What's the base?
Oh, sorry.
17. And then what's the exponent? -2. And that's equal to?
1 over.
Yep, 1 over 289. So remember that negative exponent means it's the same thing. This is the same thing as 1 over 17 squared, which is 1 over 289. So that's a true statement. Go ahead and do the U try. Number 5.
Wait, so you put the 2 8?
What? What you looking at?
Oh, because we're not making it.
We're not only, yes, that's the exponential form is a base.
Oh, I threw mine away too. Mine was just like the.
Mine wasn't very hot. My grandchild actually
It was an inheritance middle, and now I haven't tried it.
I did it. Oh, I know. I understand.
No.
Hey, everybody. I looked at, had it right. Base 15, exponent 2 equals 225. Okay, so here's a new piece of information before we go the other direction. If we have a example, log of 100 equals 2. Just like when we have a square root, say we know we have the square root of 25 equals 2. What's assumed to be right here? What's my index or root assumed to be?
That's 2.
A 2. So because I use it so much, we don't put that 2 there. We use it all the time, so we don't put it there. It's assumed to be a 2. In a log, if there's no base, assume the base is 10. So log with a base of 10 is the most commonly used log problem. Most commonly used log. It's a base of 10. So we assume it's a base of 10. Okay, on to going the other direction. I'm still writing that down. Okay, so we want to take 9 squared equals 81, and we want to change that to log form. So now we're going to go the other direction. The log, what's my base here in this equation? 9. So that's going to be the base of my log, log base 9. And then we're going to take the log base 9 of, remember, your exponent is always the answer of the log. So the 2 is going to go over here, and the 81 goes here. So it's always just switching these two when you change it to log form. Okay, so now I'm going to call in a group. So this group and the far back right. Number 7, we're going to write this in log form. What's your base? Good. So it's going to be log base 16 of a half equals 4. Good. So that answer, the exponent here, oh, no.
No. Well, no, it's
Sorry.
4 in that.
4 and then 1/2.
Yeah. You were. Log base 16 of 4 is equal to 1/2. So that exponent is your answer. So the 1/2, and again, we switch those two. So next one, number 8.
That's it.
All right, let me write that in log form, number 8. Good. He knows that that exponent, which is a 3, is the answer. What's the base? Yes. And then what goes here? What are we taking the log base 5 of? 425. Good. So again, just a reminder, since this is new to you, all of these are in the same line. They're all together. The only thing that's separate from that or at a different level is the 5. Go ahead and do
Number 6.
Oh, I did it.
Every school.
So I was gonna meet at every school. That's not even me.
You can take IU. Every school I think everything like IU.
People said that's what he was looking for.
You at every school.
Like who's like a me at like a different school.
You don't know, right?
Well, I might. Just tell me.
So log base 6 of 36 is 2. Everyone that I looked at had it right. Okay, so now the next problem, so what we're going to do is we're going to evaluate some logs. So the first part goes pretty quickly, not a lot of thinking. So now we've got a log expression. We want to evaluate it. So what might we do? What might we do to evaluate that? What might we do first? Yeah.
First, would be 11 and exponent 3.
Good. And it's equal to? Good. So he changed it first to exponential form. That's what you want to do. Change it first to exponential form. And now we're just going to simplify that. So what is 11 to the third?
Oh, 1,000.
1,331. So calculator's going to get you there, right? Learn that exponent cube.
Whoa,
Okay, number 11. This group here. Tell me what to do first.
3. X.
Good. Good. So he changed it to exponential form, and then Noah or Carolyn, what would we do next? So what we want to do is we want to get our bases the same like we did on Friday. So we're going to look at the smaller one. This is a 3, so we want to change this to a 3. 3 to what power is 81?
Sorry. You need a calculator.
Oh, man.
So when you're using a calculator, you're just doing some guess and check.
They don't have a calculator.
4, good. So 3 to the 4 equals 3 to the x. So then what is our answer? X equals 4. That's right. So we just take the bases away, and then we set those exponents equal. Okay, I'm going to skip number 12.
And 13.
I'm not skipping 13. 13 we're going to do. So 13, this group here, read, do my first step, number 13.
That's lovely. It's so good. Oh, so funny.
Equals 8, good.
This is too late for that.
So what do we want to do next to solve that? Same group.
We use road.
Well, what we want to do is we want to figure out what that base is. So we want to say, what to the third gives us 8? It's 2 to the third, that's right. So x to the third equals 2 to the third. So now we know our exponents are the same. So then our bases are the same. So x is equal to 2. Does that make sense? Okay, this group here. Set up number 14 for us. It might look hard, it's not. Good. And what's it equal to? Equals x plus 5. So now we simplify that 2 to the 4th. What is 2 to the 4th? 16 equals x plus 5. So not too bad, huh? Yeah, what's the next step? Minus 5. Then x is 11. And then 15 is very similar to 14. Go ahead and do this as a U-try. Go ahead and do number 15 as your U-try.
It's not hard. Because you're learning it right now.
If you have questions, you have those group requests. And I'm just letting you know ahead of time, I'm gonna be doing some moving around.
Oh, we can do group requests?
So if they're done, if you could put them together in the middle, and then I don't have to select
I'm really smart, so I think or this is Toshi, 7, Yeah, I gave him a bloody nose. Because it was necessary, just like trust it was necessary.
Tell me what he did.
He was being a weird guy, like touching people. And so I did that. And then I know that there was like one other significant one. There's like one really significant one, I forget. So.
We've done our best.
I've done like jokes off something. I don't see it was like much of a joke. Thank you so much. I'm just done when it's necessary for some people deserve to be so.
So Will is not here.